Next question, we are having fourth question. In this, we have given this table. So the extracted values are TP, that is true positive is 4, Fn false negative is 6, and you can go through the values. And total is 20. So the calculation classification accuracy we calculated and we get 0.30 or 30%. Precision we get 0.33. Recall we get 0.40. Type 1 error is 8. Type 2 error is 6. FI score is 0.36 and specificity is 0.30. So the importance of precision call versus accuracy is misleading when classes are imbalanced. Example, in a cancer data set, 99 people are healthy and one has a cancer. If a model predicts healthy for everyone, accuracy is 99%, but the model is useless. Recall is 0%. Recall importance in medical diagnosis. We want high recall, catch all the cancer cases, even if we get some false alarms. Precision importance in spam detection. We want high precision. We don't want to classify an important work email as spam, false, positive. Next, we have fifth question. So in this, the importance of dimensionality reduction is given. That dimensionality reduction is the process of reducing the number of random variables under consideration. It is crucial because first mitigates the curse of dimensionality, second improves computational efficiency, third reduces overfitting, and fourth visualization. So it's expect feature selection and feature extraction. So aspects are definition first. Feature selection is selecting a subset of the original feature without changing them. Feature extraction, transforming the original feature into a new lower dimensional space. Now you can go through all the aspects, that is process, interpretability, and example of feature selection and feature extraction. Next we have this is a machine learning in which input then feature is extracted. Here feature extraction is going through, then classification and then output. And in deep learning, input, feature extraction plus classification both are done together and then output. Next, sixth question in this definitions first overfitting, which is high variance. The model learns the training data too well, including the noise and fluctuations. It performs perfectly on training data but fails significantly on unseen text data. Underfitting, that is, the model is too simple to capture the underlying structure of the data. It performs poorly on the both training data and test set. Identification, you can go through of both overfitting and underfitting. Now we have here issue of overfitting and underfitting. So we have first more data, regularization, pruning, pruning, cross validation, dropout, and for underfitting, increase complexity, feature engineering, and reduce. So here is the diagram. We'll go through it. Now seventh question. In seventh question, we are given features of linear regression and logistic regression. So use case used for regression, that is predicting continuous values, example price, and logistic regression, whose use case is used for classification, predicting probabilities, classes, example yes and no. So you can go through all the features, hypothesis, cost function, graph shape, and many more. Now next we have gradient descent optimization. Gradient descent is an iterative optimization algorithm used to minimize the cost function, that is J theta. So in this first we have initialization, second we have calculate a gradient, then rate rule, and then we have repeat. Now for eighth question, we have to write a Python program to implement the logistic regression and linear regression. And for every method, compute and display the implemented models, evaluation measures, such as accuracy and other values of different evaluation matrices, such as confusion matrix, accuracy, precision, recall, F1 score, specificity, and loss function, RMSE, and R2 score. So here is the Python program. You can go through it. Next question, we have ninth question. Write one hot encoding for the given data. So here the table is given. So the concept is one hot encoding converts categorical data, that is text labels, into a numerical format that machine learning algorithms can understand. It creates a new binary column, 0 or 1, for each unique category in the feature. Processes the categorical column is fruit, unique category, that is apple, mango, orange. We create three new columns. So the resulting table is this. You can go through it. Now next 10th question. Uh, why KNN is considered as lazy learning. Discuss K nearest neighbors. Consider the following table. It consists of the height, age, and weight. Target value for 10 people. The weight value for ID 11 is missing. Predict the weight of this person, that is ID 11, based on their height and age. The table is given. So why lazy learning? So the KNN, which is K nearest neighbors, are called lazy learners because it does not learn the discriminative function from the training data during the training phase. Instead, first it simply stores the training data set. Second, all computations are deferred until a query is made, and this makes training very fast but prediction slower compared to uh, eager learners. So the numerical problem, you can go through it. And also here step 1, we calculate Euclidean distance formula. Using Euclidean distance formula we calculated it, and then we identified the nearest neighbor, that is the three closest IDs are first ID 6, whose weight is 60, ID 5 whose weight is 72, and ID 4 whose weight is 59. So prediction, since that is the regression problem, we take the average of the weight of the nearest